add it on to this one. Okay. So again, we're just going to, we don't even need to create a table of values. We can. You should be able to graph any basic logarithm graph right away. So in A, if I want to graph log base 2 of x, I know that I'm going to have an asymptote here at x equals 0. I know that I'm going to have the point 1, 0. And because the base is 2, I'm going to have the point 2, 1. I know my basic shape goes like this. So as far as a table of values, what we have on our graph right now is we know that when x is 1, y is 0. When x is 2, y is 1. But let's label some more points on here just to do some mental math. After 2, 1, what's the next nice point you could label on this graph? Right, this is the graph. And I'll do the rest of the points that we label on here in black so that we can see that those 2 blue points are the key ones that you would have. But you should be able to plug in some other numbers. What's another nice value for x that will give you a nice value for y? Sorry? 4. If you plug in 4 for x, you will get, well, log 2 of 4 is saying 2 to what exponent would be 4? You get 4, 2. Next point. $16 will work. 16 you will get 4. There's 1 in between. 8. Log 2 of 8 is asking 2 to what exponent is 8? Would be 3. So we can make a table of values and get other values on our graph as well, which helps us with seeing that shape. But again, when you're asked to graph log 2 of x, you just need 1, 0 and 2, 1. And when you're asked to graph a new graph, like in part B, we are going to graph y equals log base 2 of 2x minus 1. And we're not going to sketch them on the same grid. We're going to sketch it on a separate grid. What will that look like? Okay? So what does it look like? Set up my grid here. We are graphing log 2 of 2x minus 1. Again, you may want to take out your highlighter here and remind yourself that this 2 and this x, well, the x is really obvious that it doesn't affect any of your transformations, but this base is part of your parent graph. The log base 2 of x is part of our parent graph. So when we go from left to right and we say, what is my new graph going to look like? I'm going to look at my key points, 1, 0, and 2, 1. I'm also going to think about my only asymptote. And from our transformations unit, we always dealt with stretches and compressions first, and then translations after. As we go from left to right, the first number that's not highlighted is this big 2. What will that do? Affect the x values, affect the y values? Is it inside the function or is it outside of the function? And since it's inside, it's going to affect our x values. It's going to be a horizontal stretch or compression. We're going to multiply our x values by 1/2. And so now we got 1/2, 0, and 1, 1. Notice we had no numbers in front, so our y values are not getting stretched or compressed. And then when we go to our translations, this minus 1, is that inside the logarithm? Sometimes it's hard to tell, right? Depending on how it's written. If they wanted that minus 1 to be inside the logarithm, brackets would have been added here to really show you that that minus 1 was inside the logarithm. But now it's written as a minus 1 after. That's going to move it down 1 unit. So we will now have 1/2 negative 1 and 1 comma 0. The only thing that's going to affect your asymptote at x equals 0 is if you've had a translation left or right. In this case, our only translation was up and down, and so our asymptote will still stay the same. So what does that mean? What does that look like? Well, we can now graph our final function. Our asymptote stayed in the same place at x equals 0. We have the point 1 comma 0, and we have the point 1/2 negative 1. Label those points. And the shape is generally the same. So graphing ones we can do for practice. 7a, 8, 9, 10, and 11. But before we do that, what I would like from you is to find a partner and find a space on the whiteboard somewhere. And I'm going to give you 2 to graph. Once you've got the first one, you can go on to the second one. So y equals 4 log base 3 of x plus 1 minus 5, and y equals 2 natural log 1/2 x plus 2 minus 3.